Okay, exam 4, spring 2016. Here I have two lens system. I want to know what is the final magnification. So in order to do this, first I consider the first lens, so that P1 is equal to 30, F1 is equal to 10 centimeters. And I solve for Q1. Q1 is going to be 1 over F1 minus 1 over P1 to the negative 1. That's 1 over 10, or 3 over 30 minus 1 over 30. That's going to give me 2 over 30, and the inverse of that will be 15. So that's Q1, and then M1 is going to be negative Q over P. It's going to be negative 15 over P, which was 30, or negative 1/2. All right, so now I take the second scenario. My first image is 15 centimeters in this direction. That means this distance is 30 centimeters because the total combined distance is 45. So now I have P2 equals to 30, and my F2 is 15, and I do the same thing again. So Q2 is 1 over 15, or 2 over 30, minus 1 over 30 to the negative 1, that's 30. And then M2 is negative Q over P, negative 30, divided by P, or excuse me, I'm sorry. Wait, no, that's right. Yes, never mind, I'm sorry. That is right. Negative 30 over P, and P was equal to 30, so that's equal to negative 1. So my total magnification is the product of these two. It's going to be positive 1/2. So my final image is over here. It's upright, and it's half the size of the original image. Mirrors experience which of these aberrations? Mirrors only experience spherical aberration because chromatic aberration is due to refraction. And since mirrors do not refract light, uh, they do not experience chromatic aberration. You look at something far away, then you look at something closer. How has the focal length of your eye changed? All right, so this is your eye. If you're looking at something far away, the light rays are parallel and they'll focus at the retina. So your focal point at its longest is at your retina. And then when I look at something that's nearby, my image distance remains the same, but my focal point is going to move here. And we can see with the ray diagrams that if I draw my ray diagrams, that puts an image here, but my focal point has to be shorter, so F has decreased. Which of the following effects is the result of the fact that the index of refraction of glass will vary with wavelength? Again, that's chromatic aberration. I mentioned that in problem number 2. An object is placed at a distance of 50 centimeters from a lens along the real axis. A real image forms, so Q is equal to positive 40. It's positive because this is real, and it is on the opposite side of the object. So what is the focal length of the lens? It's fairly straightforward. The focal length of the lens is 1 over 50 plus 1 over 40. I take the inverse of that. I get 22 centimeters. So C is the right answer for number 5. Which of the following best describes the image that a convex lens forms whenever the object is a distance less than a focal point? So when the object is here, the image is here. It is an upright, enlarged, and virtual image. It's like a magnifying glass. An object is 6 centimeters, so P is 6 centimeters. From a convex lens, the lens has a focal length of 9 centimeters. Since it is convex, is 9 centimeters. What are the values of the image distance and the magnification? Well, Q is 1 over F minus 1 over P to the negative 1. Actually, let's just look because we can just figure out the answer right away. So if its object is 6 centimeters and the focal length is 9 centimeters, that means that it's inside the focal point. It's virtual, so Q has to be positive, and it is bigger, and it is upright. So it has to be A. All right, but let's just go ahead and do this. So I have 1 over 9 minus 1 over 6. Let's see, that's 2 over 18 minus 3 over 18, so that's negative 18 centimeters. And then my magnification is negative Q over P, negative 18, divided by P, which is 6, so that's positive 3. So A is the right answer. Which of these rays is drawn incorrectly? Or C is drawn incorrectly. A and B are correct. Nope. Slit has 2,000 lines per millimeter. What is the slit separation? You just take the inverse of this, and that gives you 5 times 10 to the minus 4. That's in millimeters, though. So my right answer, move that decimal place 3 more places and gives it to me in meters. 5 times 10 to the minus 7. Diffraction gradient has 12,000 lines per centimeter. How many bright spots are on the screen? So remember, with the bright spots, I need to figure out what is the order number for the maximum number of bright spots, and then I'll need to count up the actual number of bright spots. So first, let's figure out what is M. First, I have to find out D, 1 over 12,000, just like we did before. 8.3 times 10 to the minus 5. That's in meters, though, so it's 8.3 times 10 to the minus 7. Excuse me, that's in centimeters, so 10 to the minus 7 meters. And now we want to figure out what is M. M is equal to D sine theta over lambda. So that's going to be 8.3 to the minus 7 meters sine of 90. Remember, if we want to find the maximum order, we need to figure out what is M when theta is equal to 90. Because that's when the orders stop forming, because the light rays are just not reaching the screen. Over lambda, 436 times 10 to the minus 9. It's in nanometers. And let's see, if I do this, I get 8.3 times 10 to the minus 7 divided by 436 times 10 to the minus 9, and I get 1.9. That means there is only going to be one order, so my maximum M actually is 1, as I have it drawn here. So I'll see this order, I'll see the central order, and I'll see this one. So I'll have 3 bright spots on that screen. This figure shows the double slit diffraction pattern. What is the path length difference? This is 0 path lengths, half a wavelength, 1 wavelength, 1.5 wavelengths, 2 wavelengths, and 2.5 wavelengths. So B is the right answer. In Young's double slit interference apparatus, by what factor is the distance between light and dark fringes changed when the separation between the slits is doubled? So D sine theta equals M lambda. I'm doubling this. That means this is going to decrease by a half. And then the distance is given by Y equals L tan theta. If I decrease sine theta by a half, I also decrease tangent by a half, so the distance between the slits is going to be halved. Between the fringes, rather, is going to be halved. So number 12 is C. Light of wavelength 550 illuminates the double slit. What is the angle to the second order bright fringe? Okay, so M lambda equals D sine theta. Here I'm just looking for theta. So I do the inverse sine of M lambda over D, which is going to be the inverse sine of 2, 550 times 10 to the minus 9, divided by D, which is 5.2 times 10 to the minus 6. And that gives me my angle theta. It's 12 degrees. By what amount are these two waves out of phase? Well, they're shifted by a half a wavelength, and so they're out of phase by 180 degrees. But you can see this. I mean, it's sort of hard to tell how much they're shifted, but you can tell really easily. Oh, actually, no, I'm sorry. Let's see. They're not shifted by a half wavelength. They're shifted by a quarter wavelength, so it's actually 90 degrees. So C is the right answer. I can tell because I have a peak lining up with here. So it's not constructive or destructive interference, but it's something in between. So here they are separated by 1/4 wavelength, which is equivalent to 90 degrees out of phase. hold on, let me make a note about this. All right, and we're back. So two electromagnetic waves have a wavelength of 3 meters. That's our wavelength. One travels 4 meters, the other travels 2.5 meters. What do you observe on the screen when they come to that point? Well, the difference in path length is equal to 4 minus 2.5. That's equal to 1.5 meters. The wavelength is 3 meters, so the path length difference is equal to a half a wavelength. If I'm offset by a half of a wavelength, that means I get total destructive interference. So D is the right answer. All right, I have a single slit. The width is 0.2 millimeters. I have a wavelength equal to 610 meters. And then the diffraction pattern is on a screen that is 1.5 meters from the slit, so L is 1.5 meters. And I want to know the distance to the second dark fringe from the center of the bright fringe. So here, if I look at my diffraction pattern, this is my first fringe, this is my second dark fringe, that's at an order of 2. I want to know what is the distance from there to there, and that's going to be our Y. Remember, Y is equal to L tan theta. So I just need to find out what is theta, and then I can calculate y. To find theta, I do A sine theta equals m lambda. A I have, I'm looking for theta of, it's the inverse sine of m lambda over A. M is 2. Lambda is 610 times 10 to the minus 9. Divided by A, which is 0.2 times 10 to the minus 3. If I do that, let's see, I get an angle of 0.35 degrees. And then this is going to be L tan theta, so L was 1.5 meters times the tan of 0.35 degrees. And I get 9.2 times 10 to the minus 3. That's in meters, but it's equivalent to 0.92 centimeters. All right, the pitch of an individual's voice is modulated by changing the tension. The mass is set, the length is set. Although those affect the pitch, they can't change them very easily. And the size of the glottis, that just doesn't really affect the pitch at all. Labeled 1 is the larynx. That's where it contains your vocal cords and stuff. Yeah, 1 is the larynx. All right, consider this diagram. Which of these is called the cochlea? This is the cochlea, that's 6. 50 decibels is how many times as intense as 30 decibels? Well, if it's 20 decibels more, that means it's 100 times as intense. So we can think about it there. If I have 20 decibels, difference is 20 dB is 10 log of I1 over I2. And I want to know the ratio of these. So I have 20 divided by 10 is 2 equals log I over I. And I do 10 to the this, 10 to the this, and I get my ratio as 100. So E is the right answer. I stand 1 meter from a speaker and I find that it's 0.1 watts per square meter. How far do I have to go so that I have tenths, hundredths, thousandths? So I go from 1/10 of a watt per square meter to 1/1000th watts per square meter. That means I've decreased it by a factor of 100. In order to do that, I have to move 10 meters away. So I is equal to power over 4 pi r squared. All right, so if I multiply this distance by 10, I am standing at 1 meter, I move to 10 meters away, then I get 1 over 10 squared, or 1/100th of the intensity. So B is the right answer for 21. Sound has intensity level of 24 dB. What is the intensity of the sound? Okay, so already gave me the equation, but 24 dB equals 10 log of I over I naught, and I naught is that 10 to the minus 12 watts per square meter. That is our threshold of hearing. So I have 2.4 equals log. I do 10 to both sides, that gets rid of that. So 10 to the 2.4 times 10 to the minus 12 equals I. And that gives us 2.5 times 10 to the minus 10 watts per square meter. Two loudspeakers are in phase and they produce a single tone with a wavelength of 2 meters. Microphone is located 8 meters from one, 12 meters from the other. So I have one wave traveling this distance, I have another wave traveling this distance. The path length difference is 4 meters. 4 meters is 2 wavelengths. If my waves are out of phase by 2 wavelengths, I will hear a loud sound because I'll have constructive interference. All right, let me pause here for just a second. All right, two tones are played on a guitar. One is 140, the other is 143. What is the frequency of the beats? It's going to be 3 hertz. It's just the difference in those two frequencies. Consider the standing wave on a string fixed at both ends. If the length of the string is 3 meters, what is the wavelength of the standing wave? All right, so this distance is 3 meters. All right, but this is 1 wavelength. So in fact, I have this distance is 3/2 wavelengths. So I say 3 is equal to 3/2 wavelength. So wavelengths is equal to 2/3 of 3, which is 2 meters. So D is the right answer. And then also on this question, which harmonic is this? Well, I have, this would be my first harmonic. This is my second harmonic. And so this is my third harmonic. So this is my third harmonic. The tension in a guitar string is increased by a factor of 2. By what factor does the wave velocity change? All right, so this was straight from the concept test, but I have 1 over 2L square root of T over mu. If I increase this by a factor of 2, I increase this by a factor of the root 2, or 1.4. And then also V is equal to lambda times the frequency. If I increase this by 1.4, I increase this by 1.4. So A is the right answer for 27. The speed of wave is 3 meters per second, and its wavelength is 1 meter. What is 0.1 meter? What is its period? Okay, well, V is equal to wavelength over our period. That's the easiest way. You could find the frequency and then find the period if you want, but this is probably the easiest way. So I say 0.1 equals 3 over t. So what is 3 over 0.1? Well, gosh, it's 30 seconds. Is that right? Wait, no, hold on. No, I'm sorry. So V is 3 meters per second. Wavelength is 0.1 over t, and then I solve this for t, so it's 0.1 divided by 3, which is 0.03 seconds. So it's not E, I'm sorry, it's 0.03. Which of these shows the wavelength? Well, if I'm starting here, my wavelength will go to right there. So which one is this? That's B, is 29. And the speed of wavelength depends only on the medium, so C. It doesn't depend on the frequency and wavelength. V is F lambda. If I change my frequency, my wavelength decreases as long as the medium stays the same. As we discussed in class, if I'm changing the tension, like in my string, that's a different thing because I'm actually changing the medium. Okay, and I think that's it.